This is the ROS Developers Podcast, episode 63.
The ROS Developers Podcast, the ROS Developers. The ROS Developers Podcast, the ROS Developers.
Hello, ROS developers, and welcome to the ROS Developers Podcast, the podcast that gives you insights from the experts about how to program your robots with ROS. This is Ricardo Tellez from The Construct, and today I would like to dedicate this episode to all those ROS developers that are working already with ROS 2. So you are pioneering the next version of ROS. You are solving all the big bugs. You are providing all the support, all the new ideas, the ways to change ROS. So it is like you are moving on an uncharted territory. So the rest of us can come later and do an easier job. So I just wanted to thank you for all this hard work and making our ROS life easier by dedicating this episode to you guys. So thank you very much. And today we are going to talk with one of the companies that are pushing ROS 2 forward with their DDS implementation. But before going into that, let me remind you about our ROS Online Academy. Yes, at The Construct, we have created an online academy named the Robot Ignite Academy, which contains a ROS learning path for beginners. We start by teaching you Linux and Python for robotics, and then we continue teaching you all the basic ROS concepts required to become a master of ROS. We conclude with a course that teaches you how to build your own robot and how to ROSify it by adding ROS control and so other necessary ROS programs, so you can finally become a ROS developer. I'll put a link to the academy in the show notes, but basically it's a very simple link. It's called robotignite.academy. So now it is my pleasure to introduce you our invited speaker, which is called Joe Speed. Joe is the field CTO at ADLink Technology, which is a company that develops many things, but one of them is the most important for us as ROS developers is that ADLink has contributed an open source ROS middleware implementation. Joe has a lot of experience in IoT systems since he's been working on the subject for many years at Linux Foundation, and also at IBM, and now at ADLink. So today he is going to talk with us about the relation between IoT and robotics and how DDS plays a fundamental role in that relation. Welcome to the podcast, Joe.
Ricardo, real pleasure. Really love what you do there at The Construct. You're doing so much for ROS education. Dominic says great things about you, so happy to help any way we can.
Oh, thank you very much, Joe. The pleasure is ours. So we have been chatting through internet and sharing some messages, but never had the time, not even at the ROSCon, to talk directly like this. So this is the first time.
It's great.
Okay. So now I have a battery here of questions about learning about IoT, DDS, ADLink, and all that. So the first one, let me go straight with the first one. What is this thing of IoT? What does it mean?
Well, so first off, IoT, Internet of Things, is a terrible name that's been foisted upon us by the analyst and press. Those of us that have been working the space for a long time, this is machine to machine. And it's a topic I got deeply into quite a while back. I was working with some technologies at IBM. One of them was this obscure little telemetry protocol, this little proprietary telemetry protocol. Thought there was something special, spent several years getting it made open source, open standard, and convincing the automakers to use it. So that's MQTT, which is how the robots connect to the cloud.
Okay. But then this IoT thing, based on what you have answered, is more a thing about devices or kind of static things like a sensor or like a machine that is someplace and has an IP attached to it. But how does it relates to robotics then?
Yeah, so the IoT, it's very much built in robotics. If you look at like ROS2, for example, ROS2 is based on a messaging architecture using OMG DDS, a data distribution service, which is a specification from OMG, Object Management Group. I myself am on the board of directors of OMG. ADLink is the co-chair of the DDS technical committee, and so we, with others in the DDS community, we created the specification. So we co-authored the DDS specification, co-invented that, and have been working this space for very many years.
Wow. Yeah, but then, so the relation, if I have understood, I don't know, sure, please correct me if I'm wrong. So IoT uses DDS for communication. So then ROS2 uses DDS also. So that's the relation between IoT and robotics?
So within IoT, Internet of Things, you have multiple protocols, lots of open source projects. If you think about a device connecting to the cloud, there's nothing better than that than MQTT, right? It's a brokered protocol. You open an outbound connection and you broker that in the cloud. Securing cloud may not be easy, but it's easier than securing millions of devices. So you reduce your attack surface with MQTT connecting cloud, because you're able to not have any open ports. But MQTT is we talk about north-south, so north to the cloud. MQTT is the best protocol for that. But what it's not is a protocol appropriate for proximal IoT, for how applications, devices, services can discover and interoperate with each other in a proximal area, so in the same physical space, in the same machine, in the same room, in the same vehicle, in the same factory. And so for that, and you have a lot of these situations where you have requirements around needing to have latency, quality of service, and lots of other things, and that's where DDS comes in. So, DDS really comes from the military and aerospace, where you had some very difficult requirements around large, complex systems and quality of service. So, like, there's 18 navies that use one of ADLink's commercial DDS products in the ship defense systems that swat incoming missiles out of the air. So, we're very used to this, large, complex, distributed. And so what's happening in robotics is, to a roboticist, these are a lot of new technology, communications, computation problems, but many of these are topics that are well understood and well traveled in other industries. So this is why Open Robotics has standardized on using the DDS as the underpinnings, because that is a industrial grade, robust underpinnings for creating robots. So think about if you want robots to work in swarms, if you have complex robots with multiple compute, if you have system of systems, these are the DDS was created for.
Okay. I see. Then I think I understand now, more or less. But we are going to learn more about DDS in the few minutes. So, then from your answer, what I can see is that you know a lot about IoT and DDS and the different protocols that are used in IoT. And why is that? It's because prior to your work at ADLink, you also work at ABM in IoT. So were you using ROS in those projects? I mean, how was your entry into the ROS world?
Sure. So, my background in the IoT, making the MQTT open, launching IBM IoT, which became Watson IoT, getting the automakers to adopt that, and then at Linux Foundation, spinning up open source IoT programs at Linux Foundation. I really had a center of gravity not around robotics, but around vehicles, so automotive.
Okay.
So I was doing a lot of connected car, AI cockpit, a lot of autonomous vehicle projects, a lot of HMI for autonomous, right? If I have a self-driving bus, who do you talk to, right? Because bus drivers do more than just physically drive. And so really I come into ROS and robotics from the autonomous vehicle side of things.
I see. Okay, so you were working on those autonomous vehicles, and then at some point in time you decided maybe ROS is a very good tool to use it on those vehicles. Is that the picture?
It's really that me and my friends, we had a pet project of creating a self-driving bus for the elderly and disabled. And we did this as a big crowdsourced open source project with MIT, Princeton, many others. And ADLink wanted me to join. And I said, I'm too committed to, trying to solve these issues of inclusion and accessibility in transportation, in public transportation. And ADLink said, no, we love that project. Why don't you come join? You can work on it full time. You'll give your roboticists, we'll give you technology, we'll give you money for your bus. And so that's how I came into ADLink. And ADLink, this is really where I became, I knew of ROS, but had not worked with it. This is where my immersion really came because, ROS is a strategic, C-level topic at my company. It's something our CEO has a very strong interest in. In fact, our ROS team reports directly to our founder and CEO, which, we're 1,800 person company, so that's kind of a big statement.
Yes. Okay, then if you came at ADLink in contact first with ROS, maybe you went straight into ROS too, because ADLink is only working, if I am right, they are only working with ROS too. So you went straight into ROS too? Yeah.
So our company, we help companies with big, serious technology things, right? So if you look at who some of our customers are, right? We're in every GE train, we're in the Lockheed, Raytheon, Airbus, Boeing. We're in the ABB, Epson, Denso. A lot of, people with some pretty serious projects, pretty serious requirements. And so for us, ROS Classic is a terrific learning tool. But if you want to put it in production, you want to do cobots and have it interact with humans, you want it to drive safely, you want it to be reliable. These are the things where you really need this ROS 2 architecture because it's got the underpinnings to make it, fault tolerant, real time, getting to be functionally safe, right? It's got the pieces in place for us to be able to get to where we want to be.
Okay, yeah. So so I lost my thought on the question, so I'm going to continue with the next one here. So I had a question in my mind, but then I got distracted. So anyway, why is DDS important then for ROS developers?
Well, it's important because it gives you the underpinnings to have a flexible architecture, to be able to have a distributed architecture, to do swarms, to do cobots, to have robots cooperating with one another, and to have the kind of performance, like the kinds of time budgets that you need for real-time, functionally safe kinds of operations. We're not expecting that every ROS developer become a DDS expert, though. And so with DDS, DDS has great flexibility, a huge amount of configurability, which is also a problem because it has so many different options and so much configuration. How do I know what the right one is? And so we put a lot of energy into, how do we make this easy? How do we arrive at a set of defaults or building in enough adaptation and intelligence into the DDS piece of this so that ROS developers don't have to learn DDS.
Okay, yeah. So just for the beginners in ROS. So the DDS is the communication protocol underneath all the system of ROS communication between nodes and message passing and so on. And this is only available in ROS 2. And now I can link with what I wanted to tell you by the thing that you said, that is about the ROS 1 version that is used in ADLink, for example. So they are using in ADLink ROS 1, but it's just like a playground. So they are using ROS 1 for playing and then testing, learning the concepts of nodes, communications, and so on. But then when you have to do the real thing, the real stuff, then you have to move into ROS 2.
Well, I think ROS Classic is great for
ROS
education
Classic.
and academia. It needs a proper term because there is no such thing as ROS 1.
No, yeah, but that ROS Classic, I love it. ROS Classic, I love it. That's great. That's your own?
It's you got to call it something.
Okay, great.
So but where we're focused really around the ROS 2, so we do a lot around the ROS 2 education, and that's why I love what you do there at the Construct with the ROS education. So we ran ROS 2 summer schools, we ran the IEEE ROS 2 summit, which was a big event, right? It was 570 developers just for a event that was purely a ROS 2 event.
Oh, amazing. Then, there is a lot of learning. So basically, in our case, we recommend also that people start by learning ROS 1, because sure. the entry barrier, the entry point and the learning curve is a little bit smoother than the ROS 2 yet.
And that is what ADLink and many others in the technical steering committee are working to change, is making it easier. Like it's at some point, how do we get it to where whether I use ROS Classic or ROS 2, I get that same learning experience? And really, anyone who's serious, especially anyone doing mobile robots, you should go ahead and pivot to ROS 2, because if you look at where all the investment is being done around navigation and other things that you really care about, the engineering work, the investments, the latest, best algorithms, those are all going into Nav 2.
Okay, great. So ROS developers that are listening to this podcast, then give a try to ROS 2. So that's it.
Yeah.
That's it. So let's go now about this DDS specific implementation that you are doing at ADLink. So what is Eclipse Cyclone DDS?
Yeah, so that is an open source DDS implementation from the Eclipse Foundation. If you're familiar with like the Eclipse IDE or Eclipse PAHO, the reference implementation of MQTT, these are all Eclipse projects. So Eclipse Cyclone DDS, it's part of the Eclipse IoT family of open source IoT projects. Eclipse IoT is led by Bosch, and it's got a lot of big people are really involved in that, right? There's Microsoft, IBM, all kinds of companies. With the Eclipse Cyclone DDS, the things that we've really tried to focus on here, the mantra around is around, how do we make it easy, small, and fast? How do you make it very fast? So yeah, ADLink, we started it. We're a major contributor, but there are others. So there's individuals who contribute. Open Robotics contributes. Bosch, Rover Robotics, iRobot. There's a lot of people involved, and more joining all the time.
Okay, so then if people would like to use, for the beginners, when you install ROS 2, then it comes already with an implementation of DDS that is working underneath. But then one of the reasons to change to Eclipse Cyclone DDS would be exactly what you mentioned, that is because it's smaller, it's easier, and it's faster. That would be the reasons to include that one?
Yeah, I think those are big ones. Anyone doing ROS 2, especially if you're doing mobile robots, and let's be honest, like 90% of ROS 2 users are doing something mobile. Okay, so whether it's iRobot Roomba vacuum cleaners, or it's self-driving cars. Okay, they're doing mobile robotics, autonomous mobile robotics. So when you have a mobile robot, there's a few things. So you have limited compute, especially if it's a consumer product, right, or a price point product. You have limited power budget because it's mobile, so it's battery operated. So with Eclipse Cyclone DDS, your mobile robot apps, they run faster. Your robot runs for longer on a single charge. Okay, so it's easy, small, and fast, but it's also efficient. So it's doing the same work, but using with fewer computational cycles, and which has a very dramatic impact for battery life. And you look at, and it's reliable. So you look at like the NAV2, that NAV2, when you use the Cyclone DDS, it runs better, right? You can run your sensors at higher hertz. It uses less memory. It uses less CPU. It's inherently more reliable.
Okay, that's impressive. So that was one of my questions, but you already answered that. Is the how a different implementation of DDS could affect your ROS2 robot? So you actually mentioned.
Yeah. It's having a faster, smaller, more efficient RMW makes your robot work better. So really our focus, like our contribution, what we're trying to do here is how do we make open robotics easier, smaller, and faster.
Okay, great. And what about the Wi-Fi control of the robots? So does it the DDS implementation affect in any sense to make the robot more reliable when there are problems in the connectivity of the Wi-Fi for a teleoperated robot, for example? Or a robot that requires to access the cloud for some data while being autonomous. So does the DDS implementation affect in some way?
Well, it really does. You look at Changi General Hospital. They were the ROSCON keynote. And so it's a 1,000-bed hospital. So think 1,000-bed hospital. This means it's a big edifice. It's a big building. So there's lots of concrete, lots of steel reinforced concrete, all kinds of multi-path issues. They have a very good network, but what they have is a very terrible RF environment. They have an inherently difficult radio environment. So they had tried and failed with all of the other RMWs, and what we found out from them is they dropped in the Eclipse Cyclone DDS, and it just worked. And it just worked for a number of reasons. Our engineers done some really interesting work. So Eric Bossan, who is very much the architect and mastermind, or dare I say, mad scientist behind Eclipse Cyclone DDS, he developed a feature that I just euphemistically refer to as multicast auto-tune.
Okay,
so
multicast auto-tune.
Auto-tune for singers, it makes their voice sound good no matter how bad it is. So what he does is it actually looks to see if a Wi-Fi network is present, and if it is present, it makes adaptations, adjustments to the multicast profile. And so this is some work that he did. Rover Robotics, again, another company, another group working with Wi-Fi. They also found that this really worked well for them. And, so once we showed the world how to make a ROS middleware work better on Wi-Fi, and we contributed the solution to that to open source, it's great because, some weeks later, other companies, other people working on RMWs were able to, look at how we solve this, and they were able to duplicate that, which, just makes it work better for everyone.
Exactly. Okay. So, then in some sense, the quality of service is also taken into account at the DDS level.
So in this, when you say quality of service, that's a loaded term because it means specific things in DDS.
Okay.
But this was actually just about adjusting the multicast profile. So think about detecting that there's a Wi-Fi network present and then automatically adapting to do multicast discovery, but unicast messaging, unicast data.
I see.
Yeah.
So it's like it has a profile of all the Wi-Fis that are around, and then at some point in time, it only communicates with one of them, and it always knows the best one, the one that provides the best quality. And then when you have some deviation in some of the other Wi-Fi's, then automatically selects the other one and very quickly. Is that?
It's not that sophisticated.
Okay.
But it does work well. So AWS, Intel, and ADLink, we exhibited in the Las Vegas Convention Center.
I've seen the videos.
Yeah, and what you don't see is that in an environment that had, so we used a Wi-Fi sniffer, and we actually counted 666 access points.
Wow.
Yeah, it's crazy.
Wow.
It's like the RF environment. It's like the Wi-Fi environment of electronic warfare in the Las Vegas Convention Center. But even with that, Rover Robotics using the Cyclone DDS and ADLink compute modules were able to operate it quite reliably even at quite a distance. So.
Okay. So I will put a link to that video because I've seen it on your LinkedIn. You share that one, and then it's you can see how the robot is not affected by this and in working there. So very cool. Then I wanted to ask you about the difference because we said that ROS2 comes with an already made or already furnished version of DDS, which is called Fast RTPS, and then there are other implementations of DDS like Open Splice and Connect. And so, what are the differences between Cyclone and all those other three?
Sure. So Cyclone is a from scratch re-implementation. Think of it as a next generation DDS using everything that we've learned from 20 years of DDS. And the architect of Cyclone, he has this unique distinction that how for some families, like everyone in the family is a doctor or lawyer. It's like the family business, right? So Eric is a second generation DDS engineer.
Wow.
So
That's
his
interesting.
his father co-invented DDS. So he literally grew up in a DDS household even as a child, working with the technologies and thinking about it. He has like DDS logic dreams in his sleep. It's crazy. So this is very much, developed using everything we've learned from doing all the good things, all the mistakes, all the challenges, all the tricks that we've learned from 20 years of DDS development and supporting, hundreds of customers using DDS in, mission critical, life-saving situations. And the Open Splice, there's a commercial and open source, that's an ADLink. Like that's our original DDS product, for example, which is very much around large complex systems, corner cases. How can I solve every possible problem? Whereas Cyclone is really focused on the most common requirements, but making it really easy, right? So how like the design mantra between Mac OS is make the common things easy, but make all things possible, right? So if you pop into a terminal, you can go change things. But for the most part, you have this like very simplified set of things. So just think a little bit of that kind of design aesthetic, and then the Connect. So that's a closed source commercial product from another company, and with the Cyclone, this is just pure birth from scratch. Everything is done in public, in the open source, with the community, in full eye of the community, and with a lot of community contribution. So, some people give code, they pull request. We also love to give us GitHub issues. You have an idea, you have a requirement, you have a project or a need. You want help getting your project up and running with this. We're happy to, we've been helping a great many folks with this already, and we're happy to help you as well.
Oh, great. But then your project is open source, and then how do you make business with this? Or you don't make business? with or side products, or I don't know. Maybe you are rich, or your company is rich, or I don't know.
Yeah, so there is a business model behind it. It's everything is free. We'll make it up in volume. I'm sorry, that's that's an old .com bubble joke.
Okay, I didn't get it.
So the IoT software, it's very strategic. We invest much in the IoT software, in the Eclipse Cyclone DDS, and the other things that we do. But we have other things that actually fund our business, right? So, for example, manufacturing rugged robot controllers, robot controller modules for companies like ABB, Brain, Epson, Denso, all the John Deere autonomous tractors. Also things like we manufacture rugged Intel Xeon and NVIDIA GPU modules, discrete GPU modules that are used in autonomous driving systems. So we manufacture AI vision systems that, if you're listening to this podcast from a mobile, probably all the visual inspection all the way down the manufacturing line was done using our stuff. So we're coming from IBM, it feels small, but we're 1,800 people. Last year we did 350 million US.
Wow!
But very focused around this space of rugged edge compute, edge AI, and connectivity. Like this is where we live.
Wow, impressive! So I can tell you that amazing feats there, and I'm completely impressed. And then, so maybe I want to ask you another question about this. Is that
sure?
So maybe you don't know the answer because I don't know if you are the person to ask about it. Is then why does ROS2 ships with fast RTPS instead of using Cyclone? If it's an open source project, is there any reason, or maybe you don't know the answer? I don't know.
Sure. So that is the current default, and so that is the current default, and defaults change over time. So we're just very committed to provide the community with the easiest, smallest, fastest. Just we're all about making everyone's robots work better. And if people want to use ours, it is built in. It's part of it works with dashing. It's part of Eloquent. If you install from binaries, you just apt install ROS dashing RMW Cyclone DDS CPP, and you change an environment variable. So once all the pieces are in place, you can try all the different ones. You just change an environment variable and restart your application.
Okay, that was my next question about that. So how can the ROS developers that are listening, how can they actually try the Eclipse Cyclone?
Yeah, it's very easy. You can build from source. You can install from binaries. You can do an apt install. It's there.
Let me just put the steps for the beginners. So that would be yes, of course. So that would be. Go ahead.
And what we can do is put it in the. I can give you the 2 steps to put into the podcast notes. But if you install from binaries, it's apt install ROS dashing RMW Cyclone DDS CPP.
Okay, no need to command.
And then you change an environment variable. So ROS has an environment variable called RMW underscore implementation, and all that does is it tells your robot application which ROS middleware to use. So really just think of it as changing an environment variable, right? And you can flip it back and forth. You can try them all. And Rover Robotics, iRobot, a lot of people have been doing testing with the different Changi General Hospital. There's a lot of people who have done testing with the different RMWs, and some like Rover, iRobot, they've done some really nice write-ups and publication of their results. And this is especially when you think of mobile robot, inter-process, intra-process, single process, how do you make mobile robots work better? And that's where, people like iRobot and Rover are very focused.
Yeah, okay. Okay, yeah, sorry. It's because of our, my default position is always by kind of teaching or making the people to understand that's
sure.
the main purpose of our company. So that's why I always go, okay. But let's figure out the steps. So which steps? That would be install ROS2, then install Cyclone DDS, and then change the variable, and then you are.
Yes.
Okay, great. So ROS developers that are listening there, so you know the steps, very easy. But in any case, as Joe has mentioned, we'll put those steps with the specific commands on the show notes of the of the podcast.
Yeah, and, you can get some pretty dramatic improvements. So iRobot was using the default RMW, and they were failing every performance objective. It was taking up too much memory. It was using too much CPU. They were getting too many late messages. They were getting too many lost messages. And by lost, what they mean is that it didn't arrive in time to be used, so it's effectively just lost. It's outside the window. So they switched to the Cyclone DDS, and what they got is that the memory use of their ROS2 application, and this is all on ARM. They used an RPi for their dev test. It went from 153 megabytes to 15 megabytes. The CPU use dropped in half, so the robots using half as much CPU. And they went to 0 late and 0 lost messages. No lost messages. No late messages. And you can look at the data, but I think it was something like 4 times lower latency on the messaging for them. Which, think about it. If you're doing navigation, that means you can have a 4 times higher frame rate, right? You can be, instead of 20 hertz, you can do 80 hertz LiDAR. It makes latency matters. It really matters.
Yes, of course it matters, because it can, in some situations and in some applications, that could mean that the robot is achieving the goal or not achieving it. So
and as you start putting these things around people, it also makes a difference. It can make the difference between injuring a person and not injuring a person, right? In manufacturing, if you're doing CNC, it makes a difference between having a perfect part or a damaged part. There's so many, societal, personal safety, and economic issues around this topic.
Okay, so now that you're mentioning this, I'm thinking I'm going to prepare. So we are going to prepare a ROS project that we run in our cloud environment. So we have this ROS development environment, and then you can create projects there for ROS2. So you can create, the environment is already there for ROS2, for ROS1, and so on. And at present, so you can create with dashing and with the fast RTPS system by default. But we can make a project that everyone can run. So anybody that I share this project with, anybody, they can run it and see the differences. So in this project, we can do this change of the variable. We have both systems installed, and then change the variable, do a test in navigation or in any other thing. I don't know. Maybe navigation, because it's the typical one that shows more better
navigation
results.
Is a good one.
And then they can change the variable again and then see the results with the other DDS, and that would be a very clear test, reproducible.
And you would know better than I, but I would suspect most of your listeners and users and students are working around mobile robots. So I think the iRobot test harness, their use case, is a very good one.
Which one is that?
It's the one that iRobot did. I believe it's an adaptation of Apex AI's performance test. So Apex AI leads the real-time working group, and they've done amazing work around how do you take ROS2 and make it real-time and functionally safe. Doing it in the working group with Tier 4, Tier 4 representing AutoWare, all of these people. And one of the things that's interesting to me is that whether you're talking about a Roomba vacuum cleaner or a self-driving car going down the highway, they actually have a lot of the same technical needs. It's just that the scale is different, right? The scale of the scale of computation, the scale of the sensor quality and sensor quantity, the scale of the speed at which decisions must be made, but it's interesting to me that we can do a piece of work, we can develop something that helps the whole community, right? That we do this in open, and it helps all the way from the vacuum cleaners to all kinds of larger, more complex things. And so, really anyone who wants their robot to work better, you look at like the work that iRobot's done, you look at how Bosch and ADLink are working together on some things like incorporating zero copy, so you can do like LiDAR point clouds and video frames from multiple cameras at very low latency with Cyclone DDS, leveraging their work on ISROX. You look at AWS RoboMaker and the work they've been doing, the Intel ROS2 team, Robotics. And one of my favorites is this little startup, Traject Sports. They've developed a ROS2 robot that can accurately reproduce any baseball pitch thrown in a Major League Baseball game. So all the curveball, knuckle sliders, all of this, and land that ball. Think about a robot throwing a curveball and being able to land it in a very small, like few centimeters across area. It's amazing. And it also works for cricket and tennis. And so this is an exercise in extremely fast, extremely precise robotics. And they're doing it using Cyclone DDS on ADLink rugged Intel robot controller, our ROS Cube product. So this is a really sophisticated piece of work that has dozens of stepper motors and stabilizers, stereo cameras, high-speed camera, and all of this together. And what makes it all possible is this Cyclone DDS.
Amazing. So what's the name again of this robot, of this demonstration?
Oh, it's a company called Traject Sports, TRAJEKE.
Traject Sports?
Yeah, so they're kind of semi-stealth. They're the Major League Baseball, they have the winter meetings in San Diego, December 8th, and that's where all the team owners and coaches will be able to try this out.
Okay, I will look for that and put also a link because, but actually I want to see by myself also. So it's for myself because very interesting, but I will put it for the audience.
I'm going to try to see if I can organize actually bringing the Traject Sports robot to ROSCON next year and setting up a batting cage.
That would be great. That would be great. I will be there. So if you achieve that, and I will be amazed there. Okay. So now ADLink is now a member of the ROS2 Technical Steering Committee. So what is your duty on that committee?
So really our role in the Technical Steering Committee, we're just focused on how do we make ROS easier, specifiable. Like these are the things we really care about. So, part of our contribution is around the Cyclone DDS and the ROS middleware for that. We also have been making some upstream contributions. One of the things you find in the system is when you identify a bottleneck and you remove a bottleneck, you know what happens immediately? Other things break.
Oh, okay, yeah.
Yeah. So when you remove one bottleneck, all that does is it uncovers other bottlenecks. And so, we've found things in terms of, not just many people in the community, Noblio, Bosch, Apex AI, Intel, like there's so many people making iRobot, many people making great contributions that once the ROS middleware, if you can have ROS middleware not be the bottleneck and the resource hog, you begin to identify other things that are bottlenecks and cause latency and consume unnecessary amounts of resources. And so there's a lot of work been going on like, static executor and intra-process and all other things. So we're focused on that, but it's not just the RMW. So we're also working, how do we make the AI at the edge easier? So, we're partners with NVIDIA and Intel. We manufacture robot controllers with both companies. And so what can we do to make machine learning at the edge better, faster, easier, right? It's all the same mantra. So it's not just messaging, it's also the things around the machine learning that we're working on.
Okay, great. And then, so just to finalize, so what is your opinion about the adoption of ROS2 in the ROS community? How do you see the ROS2 future?
So I for me, it's inevitable that it'll be in all the things. You know, I see for ROS2 and for DDS and ROS2 what I saw years ago with the obscure telemetry protocol MQTT. Like in my head, it was just inevitable that it would be in all the things, but it wouldn't get there by itself, right? We had to do a big push, a big work, and so I did that for MQTT. That's what we're doing here with ROS2. I think in the future, you know, most things will use open source robotics, just like how today most things run open source operating systems, and most things use open source IoT. It's Dr. Freeman, the chief roboticist at Boeing. He talked to us about that. You know, for those who were involved in Linux back in the mid 90s, and you could just see it was for the people who were in the community, you could see that it was about the hockey stick and take off, and it would be in all the things. That's what he sees right now for ROS. And we agree.
Okay, great. So I also hope the same thing. Well, it's not that I hope, I know also. But I was asking you this question. I was asking you this question because I read this. There is a report made by Picnic about the usage of ROS2 and the reasons why people is not accepting, and still kind of that, like the newcomers to ROS, they are happy to jump into ROS2 because, okay, so for them, they don't know, so the latest version, it's okay. But for the companies that have been investing a lot in ROS Classic, as you say, ROS Classic, then they are still eager, like waiting there and so on. So that push that you mentioned that you did for MQTT, and then it's now the place where we are now, that we are pushing into that direction, yeah?
Mm-hmm. Yeah, it's very much so. And you know, one of the things that really helps is, you know, ROS had this reputation of being born in academia, and it's a tool for academics. Well, you know, there's a little bit of truth to that, right? That's not, you know, a complete fiction. But with ROS2, what you have is you have companies that are, they may not all be roboticists, okay? But like, look at contributions from ADLink, Canonical, AWS, Intel. We're not everyone at these companies working this are roboticists, but you know what they are? They're software engineers, they're system architects, they're really good quality assurance and test teams. And so what's happening with ROS2 is it's not just about the re-architecture to use DDS, it's that you have an entire community of corporations that are really good at software engineering, are making contributions and renovating ROS from the inside to make it world class, to make it ready for all of the really important things that are coming in the future for open robotics.
Okay, and yes, completely agree, and very good point. Especially, I like it very much, the point that you mentioned about the good software developers that are coming now, yeah, because that's one of the points also that were missing on the robotics, and especially in ROS, because it was us, the roboticists, that were doing this part of software development, and then, okay, we know how to program, but it's not our strength, the biggest strength. So now those professionals.
Well, you know, so these professionals are coming in, and like I said, just renovating, right? They're not like throwing away. And, you know, but you know what you wouldn't do is you wouldn't ask a software engineer to go figure out how do you do robots, right? Because you would get some disastrous solution from that. Yes. So I really think, you know, there's something really special going on between the people who have been in ROS for a long time, people who are serious roboticists and know the internals of it, working with these, software engineers that might be new to the community but have decades of experience doing, very serious real-time, functionally safe, high quality, all of these things, right? So like the AWS team, so they have great roboticists, and obviously Amazon Robotics is amazing. But the, AWS is like, they're really good at that whole like DevOps, iterative cycle, like with working with the cloud, now working with the edge. And so the things they're doing around, cloud-based IDE with hot deploy into the robots, that's great stuff. And the stuff that the Construct does with the, cloud-based IDE, like all of these things, I think, go together.
Okay, so very, very interesting projections for the future, and we are going to be here to see if they become true or not. We are going to push to make them true anyway. So that's all for the interview, Joe. Thank you very much for this. It's been a pleasure.
Absolutely, Ricardo. Anytime.
Okay, thank you very much. And that is all for today, listeners. So please leave us a review in iTunes telling us what do you think about the podcast and what you would like to have in the next episode. Thank you very much for your 5 stars in iTunes. Go there and give us 5 stars. We need that in order to push our podcast up. And that is all. Yes, it's finished for today. So see you next week with a new lesson from the experts. And until then, keep pushing your ROS learning.